All right, so section 5.4 is on modeling and optimization. So optimization is just a word that means finding the best of something, like finding the best size for a cereal box, the best size for a soup can, like you're going to do in your project, right? So steps in solving an optimization problem. First, you need to understand the diagram. So you need to know what's known, what are the unknowns, what are the given conditions. Use a diagram, introduce notation, use things that make sense, like A for area, S for side, L for length, and decide what's going to be maximized or minimized. So all of these are going to involve finding the maximum or minimum of something. Write an equation. You need to have the equation in terms of one variable. So yes, you can talk about volume as length times width times height, but in the end, you want them to all be in terms of like length, like one thing. And then find the absolute max or min, and if it's on a closed interval, then you have to check your endpoints too. So number one, it says you have 40 feet of fencing with which to enclose a rectangular space for a garden. Okay, so we have a rectangle. All right, and you have 40 feet. So yes, you can say that we have the length and the width. Okay, but we know that length plus width plus length plus width has to equal 40, right? That's going to allow us to get our other equation in terms of one variable. So a lot of times you'll have two equations. Okay, find the largest area. That means we're trying to find the max area. That can be enclosed with this much fencing and the dimensions of the corresponding garden. So the equation that we're trying to maximize is A. A equals L times W. So right now we have it in two variables. We have length and width. We only want one variable. Okay, so we go back to that other equation and we say, oh, well, 2L plus 2W equals 40. So if I wanted to solve for L, I would have 40 minus 2W equals 2L. So I would divide by 2 on both sides and get 20 minus W. Okay, so we get A equals L, which is 20 minus W, times W. So you have that. Okay, now we have an equation that only has one variable. It's like, I guess it has two variables, right? It has A and W, but it's like a function in terms of W. Okay, now we all know how to maximize this. You could do this even without calculus because you learned algebra 2 and you know that it's a parabola that's downwards and you could find the vertex with negative b over 2a. Do you guys remember that? Do you guys know that that came from calculus? It's very exciting. Side note, you don't have to write this down, but ax squared plus bx plus c, if you have a parabola and you want to find the maximum or the minimum of it, y prime is equal to 2ax plus b. You set it equal to 0. Right? You get negative b over 2a equals x. Oh my gosh. Like everything you've ever learned is calculus. It's blowing your mind. Yes, I know. All right. Negative b over 2a. Do you remember that from algebra 2? Yeah. So then that would find the axis of symmetry. Then you can plug it in, find the vertex. All right. So anyway, so we have this. So we're trying to maximize a. Right now we know it's a downwards parabola. So I'm going to do a prime. I get 20 minus 2w. I set it equal to 0. So 20 minus 2w. So 2w equals 20. Oops. So w equals 10 then. Okay, and you need to justify that this is indeed the maximum and not the minimum. You could do that by just noticing that you have a downwards parabola, right? And you could say, oh, clearly it's a maximum. But you would need to write out some kind of justification. So usually what I do is I do like a number line. And I plug in 10, and I say, okay, well, it's positive and then it's negative, so it goes up and down. But remember, they don't grade the number line, so you would need to write out a prime is greater than 0 on negative infinity to 10, and a prime is less than 0 on 10 to infinity, therefore a max at 10. Okay? Now the question said find the largest area. We have found the value for W, but we haven't actually found the maximum area. So we have W equals 10. So that means L is 20 minus W. So 20 minus 10. So L is also 10. So your max area is 10 times 10. So it's going to be 100 square feet. And your dimensions are 10 feet by 10 feet. That's it. So make sure you solve what the question asks for. Okay, that's like as easy as they get. It's pretty easy, isn't it? That wasn't that bad. You guys understand that. Yeah, sorry, I shouldn't have phrased it that way. This is as easy as it is. All right. 10 feet. Yeah. All right, so next one. So it says a square sheet of cardboard, 18 inches on a side. You guys have all done this before, right? In Algebra 2, there's not even cut the little squares out. You can see this. Yeah. It's made into an open box by cutting squares of equal size out from the corners.
Sorry, I heard disruption.
Just hacking up along over there. All right, so basically, guys, if you cut out, like, I've shown you this little experiment before. If you cut out something like this, like you don't cut out a square, then this little flappy part here, like, folds up, and it's really, really tall, like, really tall. But then this part right here folds up, right, and it's really short. You're not getting, like, a box that has an even top. You guys understand what I'm saying? Okay, so it needs to be a square that you're cutting out from each side. I don't even know what I just did there. All right. Look at this. Okay, so when we cut these little squares of equal size out, like we have x by x on each one. Right, like it's really easy to teach when people are talking. It's very distracting. All right, so we're trying to find the dimensions of the box with a maximum volume. So our volume equation, as we fold these little pieces up, it becomes this like really shallow box, like a gift box. We have x. And then we have these two measurements right here. What are those going to be? Exactly, it was here. So it's 18 minus 2x, because you subtract x from both sides. So this one is 18 minus 2x. If you can't draw a brace, it's okay. Beautiful. Oh, yes. A nice box. I thought you were saying the brace thing you couldn't draw. All right, so that means we have 18 minus 2x times 18 minus 2x times x for our volume.
18 times 18 minus 2x.
18 minus 2x. So we could multiply it out. Do you guys know 18 squared?
126.
Nope.
324.
So 324. We have minus 36x minus 36x, so minus 72x, and then plus 4x squared. And then we're going to multiply that x in. So your volume is going to be 4x cubed minus 72x squared plus 324x. I multiplied it out because it was going to be a lot easier than doing the product rule with 3 pieces. You could do the product rule with 3 pieces, but we won't do that. Yeah. All right, so b prime is going to be 12x squared minus 144x plus 324. Okay, so we need to set it equal to 0. Does 12 go into 324? Let me guys do that one. I think it does, yeah.
Let's say it's what's like.
It does. Got it.
27?
The last number. It was 7? Right.
27.
Oh, that was the.
All right. There's a rule for 12. I didn't know that.
I think if it goes into the last 2 numbers, it's supposed to happen. That could not be true.
All right.
It's 4.
So I have x minus 3, x minus 9. Right? So we get x equals 3 and we get x equals 9. One of these does not make sense based on your picture. 9 does not make sense. 9 is actually going to be the minimum volume. Think about it.
0.
Because there's going to be no volume whatsoever because you're cutting out x is 9 from both sides, right? So you're not going to have any, like, width. It'd be like 0, 0, 9, right? Like, it's 0. All right. So the 9's out. It doesn't work. Okay, so you could still do your number line, and you could put 3 and 9 on there. In this case, you'd also have 0 because you wouldn't have anything over here, right? You can't have like a, same thing with the last one, like you could actually put 0 here because you're not going to because you're not going to have like a negative length or a negative thing that you're cutting out. Yeah. No, you don't have to. It's just like one less thing that you should contract. Can you what? All right, so if you try each one, it ends up going like positive and then negative there, which is what you wanted to do. So you can try them in B prime.
Like we just put the 3 on the number line, and that's all you really need, right?
Yeah, like the 3 is really all you're worried about. You're really just worried about like before 3 it was increasing, like f of x or v of, in this case v of x was increasing, and then after 3 it was decreasing. Just say that there's a maximum. Yeah.
Why did you make a squiggly line before the 0?
Because like there's not going to be a negative
Right.
x. All right, so really, I'm not too concerned about that on your homework. I'm just reminding you on your AP test, you can't just do the little sign chart. You have to describe why you know it's a max and not a min. Okay, so x is equal to 3. So if x is 3, then when you plug into these things, 18 minus 2x, you get 12. So both of those are 12. So your max volume is 12 by 12 by 3. So 144 times 3. So 432. So max volume equals 432 square inches, or cubic inches. Almost. You almost got your point. All right, and then the dimensions. Yeah, are 12 inches by 12 inches by 3 inches. You can write out IN. Yeah, you would need to, if you were going to describe that. But I was saying on your homework, you don't need to. So I'm going to kind of shortcut it now. But if you're on your AP test, don't forget that. All right, we good? Do you guys like optimizing?
No.
No?
I just thought I was
All right. So you're saying it's really graphing, it's just you, or I'm pretending it's not graphing, but it really is graphing. All right, so find the point on the parabola 9 minus x squared closest to the point 3, 9. All right, so here's what the sketch looks like. 9 minus x squared, 1, 2, 3, 4, 5, 6, 7, 8, 9. It goes through 0, 9. What's the x-intercepts for this?
3.
Good job, 3 and negative 3. Right, because if you set it equal to 0, you'd get 3 and negative 3, which are zeros. All right, we want closest to the point 3, 9. So 3, 9 is like right here. And the point that's going to be closest to it is going to be somewhere in here. It ends up being like perpendicular to the tangent line. That's a geometry fact. You guys haven't learned that in geometry. Does it make sense? Because if it wasn't going to be perpendicular, like let's say we had another line here, that's clearly longer than this one because that's a hypotenuse. To be drawn a little triangle. Do you guys kind of understand that concept? Like anything else would be much larger. Thought you were done with geometry? Yeah. All right. So we need to find the point closest. When it says closest, what am I minimizing? No, the slope has to be perpendicular, but if I say I want you to be very close to me, I want you to minimize your blank from me, yes, minimum distance. So we're going to use the distance formula.
No. What? No. Okay, let's do it.
All right, so this is the point 3, 9. Oh, God. All right, this point that I've marked in blue, this point is in the form x, 9 minus x squared. Do you guys understand that? Like at some point on the parabola 9 minus x squared. So whatever x value you have, the y value is just 9 minus x squared. Yeah. Like if I asked you 1 comma something is on this parabola, what would you do to find the y value? you would plug into the equation. So you'd have 9 minus 1 squared. It would be 8, right? So if I have x, then the y value is 9 minus x squared.
Weird, I should thought we could do that. Like, okay.
All right, so we want to minimize the distance between those 2 points. So distance between 3, 9 and any point on the curve. So, and x, 9 minus x squared. So it's going to be d equals the square root of x minus 3 squared plus 9 minus x squared minus 9 squared.
Where do you get the exponents today?
I'm doing the distance formula. This is my x2, y2. This is my x1, y1. Remember, x2 minus x1 squared plus y2 minus y1 squared. Do you guys remember the distance formula? Do you need me to write it down?
A little bit.
x2 minus x1 squared plus y2 minus y1 squared. Oops.
Oh.
It comes from the Pythagorean theorem. A squared plus b squared equals c squared. It's just c squared has been, we took the square root of it. All right. So I get d equals the square root of x squared plus minus 6x plus 9, and now she got me, minus x squared is going to be plus x to the fourth, because the negative is going to be squared. That's what we're minimizing. Okay, if you want to rewrite so that you see like raised to the 1/2, you can. It's x to the fourth plus x squared minus 6x plus 9 raised to the 1/2. So we're doing chain rule, right? Oops, that's my phone. That's annoying. All right. Just ignore it. You can, if it's bothering you, you can turn it off. Hopefully it's not my child at daycare has puked everywhere or something. That's always fun.
Did he feel sick earlier?
Yeah, he's been felt sick for a couple days. He's always sick though. He's a sickly boy. He is.
Why don't you sleep?
He throws up in the car whenever we're in the car for more than an hour. Like, we can predict the exit that we're going to pass on our way to Muncie, like where he's going to puke. I take a bucket and I'm like, okay. Yes. Like, he's just
That's so weird.
sick child.
Does he get car sick?
Yes.
No.
All right. All right. So anyway, the derivative of the inside is going to be 4x cubed plus 2x minus 6. All right, now it looks gross, I agree, and you're worried about setting it equal to 0, I'm sure, but think about it. Actually, this one is kind of gross.
That's helpful.
Because it's an x cubed. All right, what you're worried about. All right, you're worried about setting this whole thing equal to 0, right? It's a fraction. The only way it's going to equal 0 is if the numerator is equal to 0. Agreed? Set the numerator equal to 0.
Okay.
I'm even going to get fancy, and I'm going to pull out the common factor, which is 2. So I'm going to have 2x cubed plus x minus 3. Can you tell a number that goes into that? That would make that equal to 0. It's very easy. Think about an easy number. I heard someone say it. 1. 1 makes that equal to 0. Do you guys see it? If you plug in 1, 2 plus 1 minus 3 is indeed 0. So x equals 1. But we need to see if there's any other points that would work. This is busting out all your Algebra 2 skills. If you know 1 is a 0, what can you do to factor this? Huh? And how do you divide by x minus 1? So 2, 0, 1, negative 3. Drop the 2. I put in a 0 because there's no x squared. 1 times 2 is 2. Add straight down, I get 2. 1 times 2 is 2. Add straight down, I get 3. 1 times 3 is 3. Add straight down, I get 0.
Wait.
No one's listening. All right, you have now factored write it down here. You've now factored into x minus 1, 2x squared plus 2x plus 3, and you have a 2 out front. So your numerator factored into that. Luckily, the second part, the places where it's equal to 0 are I values. Okay, do you guys remember the word discriminant from Algebra 2?
Yes.
Yeah, it's like the part under the square root. Like if I did quadratic formula, I would do b squared minus 4ac, right? b squared minus 4ac in this case is a negative number. B squared is 4 minus 4 times a times c, that's negative. So it's not going to give you any additional solutions. Do you guys understand what I mean by that? Like you could try to do quadratic formula to find the answers, but they're going to be I answers. So the only answer you have is x equals 1. So what is the point? What's the point? Find the point. So 1 comma 8, that's it.
Wait, why did they do when you were
That's funny. I'm just so smart. I knew it was going to be 1 comma 8. All right. That's pretty difficult. That's as hard as I get.
Really?
Yeah. There are a lot of steps, yeah. All right, number 4. So you want to construct a box. Shh, guys, you want to construct a box whose base is 3 times the base width. Base length is 3 times the base width. So we have this. So let's let W be width. The length is going to be 3 times that. So 3W. The material used to build the top and bottom costs $10 per square feet. And the material used to build the sides costs $6 per square feet. If the box must have a volume of 50 cubic feet. Do you guys see what that's going to allow us to find? It's going to allow us to talk about the height of the box as well. We're going to be able to solve for h in terms of W. So the first thing we have is the volume of 50 cubic feet. So we have that 3W times h has to equal 50. Okay, that has nothing to do with the thing that I'm trying to maximize. It's just another equation that allows me to get everything in terms of one variable. So I have h is equal to 50 over 3w squared. Did you guys see how I got that? Just divide it over. So this height is really 50 over 3w squared. Let's say equals h. All right, so we need to come up with, what are we trying to minimize in this case? Minimize the cost to build a box, right? So let's talk about the cost equation. So C for cost. I'll even write it out, cost. All right, so we need to talk about like the front, the back, the right, the left, and the top, and the bottom. Okay, bottom is important in a box. Okay, so we want the box, the top and the bottom. Oops, I crossed it out. The top and the bottom cost $10 per square foot. Okay, so let's talk about the top and the bottom of the box. Okay, the area of the top and the bottom, each one is 3w squared. You guys see it? So you're going to have 3w squared, and then times the $10, but then times 2, because you have both the top and the bottom. The 10, it's the cost right here, the $10 per square foot.
So why do we do 3w squared?
Because that's the area of the top and the bottom. So
Right.
Each area is 3w squared. The price for that 3w squared is $10 per square foot. And then we have 2 of them. Okay, now let's talk about the right and the left. Okay, the right and the left are going to be w times h, but in our case, h we found is 50 over 3w squared. So we have w times 50 over 3w squared. So the w's will reduce. That's the area. How much are they costing? $6 per square feet. So times 6 times 2, because we have the right and left. Okay. I'm not done. I just ran out of room. So plus, now we need the front and the back. Okay, the front is 3w times 50 over 3w squared. So that's the area of the front and the back. They each cost, it's still considered a side, right? 6. And then we have 2. So that's the front and back. Okay, so clean it up. So go ahead and try to simplify. Write it so that you have like w to the -1 in certain cases, right? You want to be able to take the derivative easily. So go ahead and simplify. Hang on. All right, so what'd you guys get? So you have 20 times 3, so 60w squared. I forgot my little plus there. Plus 200 over, what is it? Oh, did I lose my 6 when I copied? So was there a 6? So should it be 360 w squared? What are you saying? Okay. Okay, so it should be 60 w squared? Okay, plus, so, is it 200? Yeah, 200 w to the -1.
Oh, yes.
Yeah, because the w and the w squared make a w on the denominator, so that's w to the -1.
So we can't write 200 over W.
You can do 200 over w, but remember you're getting ready to take the derivative. And it's easiest if you do 200 w to the -1. All right, and then 3 and 3. So 600 w to the -1, like that. So you really have 60 w squared plus 800 w to the -1. Did you guys get that? All right, so that's cost. Okay, we haven't taken the derivative at all. So now we take the derivative. So C prime is going to be 120 w minus 800 w to the -2. And I want to set it equal to 0. So remember, whenever I have like a negative exponent, you always want to write it so that you have a positive exponent on the denominator, and then you want to get common denominators. So you're going to multiply by w squared over w squared. So that you get 0 equals 120 w cubed minus 800 all over w squared. Because really, critical values come from numerators and denominators. So that's really why you should do that. I mean, yes, you could shortcut things, and in this case, you could actually like subtract or add this part over here and then cross multiply. It's just kind of a bad habit to get into because you're losing the fact that w equals 0 is a critical value. Do you guys understand what I mean by that? Yeah, because you would like end up not having w equals 0. Okay, so anyway, so we have numerator equals 0. I multiplied by w squared over w squared to get common denominators. Okay, so I'm going to add the 800 over, so I get 120 w cubed equals 800 divided by 120. It's a pretty one, so it's 6.6 repeating. So you get w is equal to 2.582. I rounded to 3 decimal places. You might want to store it just in case. I'm going to store as alpha A just in case. And then I'm going to remind myself that I stored it as A. You guys really like Stowe, don't you? Is that what you're saying? Yes, I know. All right, so basically you want to verify that this is the minimum. So you would still think about your number line, C prime. You'd put 0, a critical value, and 2.582 on there. And if you try like 1 in the derivative, so if I try 1 here or here, I would get 120 minus 800, so it's negative.
Is 0 critical value for this?
Yes. And if I try something like 3, then I end up getting like 360 minus 800 over 9, which is going to be positive. So since it goes down and then up, yes, it is a minimum.
Wait. Is that an arrow instead of dot?
Probably an arrow. Yeah, arrow. All right, so what did it ask for? Did it ask for the dimensions? Yeah, so your dimensions, so if you go back to your picture, you have 3w times w, and then you had 50 over 3w squared. So your dimensions are going to be, that's why I told you to store it. So you have 2.582, that's the w, and then times 3. So the 3W is 7.746. And then 3, like you got to do the 50 divided by 3W squared, so I'm going to do 3A squared.
Is it still defined on height or is it still on cost?
I'm still on the cost.
Okay.
Well, I'm not on the cost. I'm finding the dimensions. Like it was 3W, or it was W by 3W by 50 over 3W squared, right? That was like the length with height,
Right.
with length height. All right, so the last one is it 2.5? Did you guys get that? Yeah? Units? Feet? So just do your little tick mark for feet. Or you could write FT. All right, and that's your answer. So there's your dimensions. So don't let the word scare you. You are an AP Calc now. You can handle story problems, I promise. You can do this.
I don't even struggle with that so much.
I will hold your hand if you need me to hold your hand, but I think you can do it. Yeah, it's a long one, yeah. All right, next up. Is it break time? All right, you guys can all break. All right, so a printer needs to make a poster that will have a total of 200 square inches and will have a 1-inch margin on the side and a 2-inch margin on the top and a 1.5 on the bottom. Okay, so draw a picture, right? So you have a poster. It's going to have a 1-inch margin on the sides, a 2-inch margin along the top, and a 1.5 along the bottom. Okay. Okay, we're trying to maximize the printed area. So the printed area is this part here. The poster, the total poster. Okay, so the poster has a total area of 200 square inches. So there's 2 ways you can approach this problem, and I think I have the opposite one on your homework. So mean of me. All right, so what you could do is you could let like this be y and this be x. That way your total area of 200 square inches becomes 200 is equal to x times y. That's how I would do it, because it's going to be very easy to solve for x or y. Do you guys see how like you could do 200 over x is equal to y? That's the best way. Okay, but I think
Let's do that.
I think on your homework what I said is I want you to maximize the total poster, and the total poster has a total area of something. That's when you well, I didn't say the total poster, I said the printed area has a total area of whatever. That's when you would want the inside part to be your x times y. Okay, you can do it either way. Like you can make your x times y be the total outside part, or you can make the x times y be the printed part. It doesn't matter. It's just going to be much easier if you do it this way for this example. Okay, so we want the largest printed area. So if I talk about the printed area, the total length along the side was y, and now I'm subtracting out 2 and 1.5, right? So what are you going to have? Yeah, y minus 3.5. And then this other one was originally x, like all the way out, but I'm subtracting 1 and 1, right? So it's going to be x minus 2. So the area that I'm trying to maximize is x minus 2 times y minus 3.5. Okay. So I need it all in terms of one variable, like a of x. So I'm going to replace the y, yeah. So I'm going to have x minus 2, and then I'm going to have 200 over x minus 3.5. This is what I was talking about. This is what makes this easier, because if you had done it the other way and you let the inside part be the x and y, then when you replace, you're going to have like x minus something there, and you're going to have to do the chain rule. Do you guys understand? Like when you take the derivative? Okay. Okay, so we have that. So let's go ahead and multiply all out. So I have x times 200 over x, so I get 200. I have x times 3.5, so I have negative 3.5x. I have negative 2 times 200 over x, so negative 400 over x, or you can say x to the negative 1. And then I have negative 2 times negative 3.5, so I get plus 7. So I have A equals 207 minus 3.5x minus 400 x to the negative 1. They've been playing strange games in Spanish all day today. They were playing, I swear, musical chairs earlier. You were? Okay. During a test of mine. A little distracting. All right, anyway, so A prime is going to be negative 3.5 plus 400 x to the negative 2. So you have 0 equals negative 3.5 plus 400 over x squared. So remember, this is a situation where you would need to get common denominators. So you're going to multiply by x squared over x squared. So you get 400 minus 3.5x squared all over x squared equals 0. And like I said before, like you don't need to do that like necessarily. Like you could add the 3.5 over, multiply the x squared, right, and solve for x squared that way. But like you really should consider that you have another critical value at 0. Like if you do that, you're missing out on your critical value. All right, so set equal to 0. So what do we get? So 400 divided by 3.5 square root. So I get x equals 10.690. It is plus or minus, but since x is a length, you can ignore the negative one. Just know there's no negative, but x is a length, right? Are you going to have a negative size for your question? You guys know what I'm saying? Yeah, so like on these optimization ones, you probably won't have a negative.
Math never ceases.
That's quite a bit. Math never ceases to amaze me. All right. So you can do your number line. So you have 0 and you have 10.690. Like I said before, like you can ignore anything that's over that. Right? It's negative. It's a length. Get rid of it. All right. And then if you plug into A prime, so let's say I plug into this right here, and I plug in 1, I get negative 3.5 plus 400 over 1. So I get 400 minus 3.5, it's positive. And if I try like 11, right, it's going to be negative. So you get up and then down. So that is going to maximize the printed area. So what dimensions of the poster is your final answer? So it's going to be 10.690 inches by, what was the other one? So 200 divided by that, 18.708 inches. So I found y by doing 200 divided by x. And I had it stored because I'm a good calc teacher. I used my answer key, right? So that's your answer. Okay.
Still there.
All right, there's one last one that I want you guys to see because it's on your homework. So the last one is on a Norman window.
Norman?
A Norman.
Oh.
I don't know who Norman is. Yeah?
You said a store, but can't on
On your calculator, you can go up.
yeah.
Yeah, that's fine. Yeah, mine I can't. Mine doesn't let me go up and grab the last thing. It's very nice that you can do that. Like on your calculator, you can like go back up, like hit arrow up and get another number. All right, so it says a window is being built, and the bottom is a rectangle, and the top is a semicircle. Have you guys seen these windows before?
Nope.
All right, it's called a Norman window. Norman window. That's what it's called, a Norman window, yes. Okay.
Family built those windows.
Oh, they did. Hannah Norman's family built those windows. All right, if there are 12 meters of framing materials, what must the dimensions of the window be to let in the most light? So these Norman windows, I mean, I drew this this line across, but it's really like, it's not really there. Like sometimes there are, like sometimes you see like a little wood piece or whatever, but it's not going to be there. This is just messy. I don't like it. You get cleaner.
Yeah, mine.
Okay. So the window's being built and the bottom is a rectangle. So there's 12 meters of framing material. So the key to doing these problems is to go across and make that X. Mm-hmm. All right, and then you need to talk about like the distance across. Mhm. So it's half the circumference.
Oh my God.
I knew it.
All right, so it's going to be 1/2 2 pi r. So in our case, our r is x. It's going to be pi x. All right, and then you have 2x along the bottom, right? And then we have some kind of height here. We don't know. So I'm going to call that y for now. All right, so we have 12 meters of framing material. So the 12 meters of framing is going to go all the way around the outside of the window. You can actually bend wood. You just know that, right? You can bend wood into like that circular shape. So you're going to have 12 is equal to the pi x plus y plus 2x plus y, and that's it, right? So we have the pi x, we have y, we have 2x, and then we have y. That's not the one that we're maximizing. That's not the equation that we're optimizing, you know. We're trying to find the most light. What does that mean to find the most light? Max area, right? Okay, so we're going to have a second equation. Okay, so our second equation that we're going to maximize is A equals, and we have a rectangle, and then we have half of a circle. So we're going to have 2xy plus, whoops, what's the area of the semicircle?
Pi r squared.
Pi r squared divided by 2, right? Or 1/2 pi r squared. But r in our case is x, right? So pi x squared. All right. So I need everything in terms of one variable. I need only x's, so I need to solve for y. And this is where it gets a little bit like messy. Okay, so I'm going to solve for y. So I have pi x plus 2y plus 2x, right? Because I had 2 y's over there. Yeah, that's a pi. Is it not up to your standards? So I have 12 minus pi x minus 2x equals 2y. So I'm going to divide by 2. So I have 6 minus, I'm going to write it as pi over 2x minus x. You with me? Yeah. So your area is going to be 2x times 6 minus pi over 2x minus x. That was the y. Plus 1/2 pi x squared. Yeah, I saw for y. No, we're not done. We still have to like simplify, take the derivative, start equal to 0, and so on. Because the only thing that's scaring you is that there's a pi in the problem. Like,
And it's just
if that was a 5, you'd be like, oh yeah, 5, all right.
yeah.
2.5, I got this, combine my terms, it'll be
And
fine.
it's just wrong.
All right,
But you can think of it.
And there you go.
so I'm going to have 12x minus 2x times pi over 2x. The 2's are going to cancel, so you're going to have minus pi x squared. And then I'm going to have minus 2x squared plus 1/2 pi x squared. So I'm going to write pi over 2x squared. I'm going to combine the 1/2 and the pi. Do you guys see I did 1/2 times pi, and I wrote pi over 2. All right, ready for the derivative? Yeah, you could combine like the pi and the 2 and stuff. I'm not going to. I'm going to separate. All right, so a prime is going to be derivative of 12x is 12 minus the derivative of pi x squared is what? 2 pi x. Then I have minus 4x plus pi over 2 times 2 is pi, so pi x. I'm going to set it equal to 0. So I'm going to have 0 equals 12 minus 2 pi x. I really have a plus pi x, so maybe I'll combine those. So I have a negative 2 pi x plus pi x. What's that going to be? Minus pi x minus 4x. All right, I need to solve for x. Subtract 12. And then I have negative pi x minus 4x. I'm going to pull out the x. So I have negative pi minus 4. And then I'm going to divide. So I end up getting x equals negative 12 over negative pi minus 4. All right, this is where we're going to utilize our stow button. I get 1.680. Did you guys get that? All right, store. All right, that's x. So we want the dimensions of the window. It's kind of weird, like, how do you talk about the dimensions of this window? I would probably talk about, like, the 2x by the y, right? So I'd probably just draw, like, a little rough sketch. I think it ends up, like more like this. So 2x is going to be, so times 2, so 3.360. And then the y, what was y? Where was y? This. So I'm going to plug in there. So I have 6 minus pi divided by 2 times my alpha a that I stored minus alpha a. Did you guys get 1.680 as well? Y ends up being the same as x. I plugged in to find y. I plugged in here to find what y was. It actually ended up being the same as x. Kind of. Okay. Think you can do a Norman window one?
So like, what's the answer?
It's kind of weird to like talk about the dimensions of a window like that because it's like how do you get your? So I just kind of drew like a little rough sketch, so you could see this length and this length make the best window. And it's in meters, so I guess I should say meters.